Before we start this lesson on Sentinel Controlled loops, I want to talk a little bit about a problem that beginning programmers tend to make. If you recall our previous lesson on count control loops, I introduced a program that replicated multiplication using loops and addition. Here's a look at the program. Let's build and run it just to refresh our memory of what it does. We enter a first number and a second number, and it multiplies the first number by the second number. It is very common for beginning programmers to forget to initialize variables. If you recall, initializing a variable gives it a value after it's been declared. In C++, you have to initialize a variable with a value of your own choosing, or C++ will go out to the memory location where the variable is and pull in whatever random memory there is. So let's look at what happens if you forget to initialize the variables product and count. I've commented them out to resemble not initializing them at all. Let's build and run the program. We enter the first number 5, the second number 3, and you'll see that we get the value 4,201,286, which is not the real result of multiplying 5 times 3. What happened is that C++ went out and grabbed the memory for both of those variables, product and count, and that's what we got. In fact, this would work even if we initialize one variable and not the other one. So let's initialize count because we're thinking about our loop, but we might forget product. Build and run again, 5 and 3. You see we get a different value, but it's still not the one we're looking for. So let's fix the problem, initialize both variables, build and run, 5, 3, gives us 15. And that's what we want. So remember when you're starting a program to always initialize the variables that you're going to be using in your solution. Now let's move to our topic for this lesson, which is Sentinel Controlled loops. A Sentinel Controlled loop looks for a special value as a means of stopping the loop. So for example, if we were reading data from a file, we might look for the end of the file as the sentinel to stop the loop. We haven't talked about file reading yet or working with files, so we can't use that as an example. But what we can use is a program that accumulates a set of grades in order to compute the average. The sentinel for this example will be a value that could not represent a grade, such as -1. Even the meanest grader won't give a negative grade for a test. You'd give a 0 as the smallest amount. So we might enter some values for a program like this by typing in some numbers. And then when we've reached the last grade, for the next grade, we enter -1. That signals the program to stop the loop and compute the average. Let's look at a program that does that. We'll delete what we've worked on previously. So we begin by creating some variables. Grade will store the grade that we enter from the keyboard. Grade total will keep our running total of grades. And num grades will keep count of how many grades we've entered. Then we need a variable for the average, double average. Now we need to initialize our variables. We need to initialize num grades and grade total to 0, so we're going to use a special shortcut, num grades equals grade total equals 0, which is a shortcut way of saying grade total equals 0 and num grades equals grade total, which is the same thing as setting them both to 0. Now we're ready to enter the first grade. We do that before the loop because we have to have a grade to compare to -1. So this is just like initializing the loop control variable to a value, except this time we're prompting the user to enter that themselves. So we say while grade is not equal to -1, add that grade to the total of the grades. Increment our number of grades because now we've entered another grade to the total, and then prompt again. Rather than type it all in again, let's just copy and paste. Control C, Control V, get our prompt in the right place, and that ends the loop. This loop will run as long as the user enters a value other than -1. Then once -1 is entered, we're ready to compute the average, which is just the grade total divided by the number of grades, and then we'll write out a response. And there we go. Let's build and run the program. We'll try it with 3 even grades first, just to make sure we've got it right. 70, 80, and 90. -1, that's the Sentinel value that says stop the loop and compute the average, and we see that the average is 80. Let's run it one more time with a little larger set of numbers. 78, 89, 93, oops, always an outlier. We'll have another outlier, although 100's not so bad as an outlier. -1. And we'll have to assume that's correct. I can't do that in my head anymore. Actually, I could never have done that in my head. So you see how a Sentinel value can be used to control a loop. In the next video, we'll look at one last type of loop, a results controlled loop.